Greetings again, living environment fans from across the United States, its territories, all of Canada, provinces, and Newfoundland. It's time for today's Bellringer. And of course, we've been talking about DNA and DNA replication. We're going to move into talking about transcription and translation today. So that's where we're headed. Let's do a little DNA. It's a Tuesday. Love it.
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
Right, we've been into replication. That's when a DNA strand splits in half and then makes two copies of itself. It does that right before cell division. We haven't really talked about anymore about that, but that happens, right? Replication. It requires some enzymes, including helicase, of course, and then helicase splits the strand, and then of course you've got polymerase, DNA polymerase, which matches up the A's to T's, C's with G's, resulting in two new strands. Transcription happens also in the nucleus. In transcription, you don't make two new strands, you just make part of one strand, and you make a strand of mRNA. You still need a helicase to split the strands, and then you use an RNA polymerase. And the difference between RNA polymerase and DNA polymerase is that, of course, you match C with G, right? But you match T with A, but in RNA you match A with U. A doesn't match with T, A matches with U. There's no U in DNA, but there's U in mRNA. And U is a chemical called uracil. And we call that, this is called the gene or strip of mRNA, messenger RNA. All right, so RNA polymerase is the enzyme. It splits the DNA molecule and then it copies one half. A goes with U, right? G goes with C. T goes with A, so that gets a little confusing, but you'll figure that out for sure, right? When you split. And then this section here of mRNA is called a gene, and it's made up of codons. All right, so here's the section of DNA, split in half, and then you match A with U, T with A, G with C, C with G. Okay, so it's a little bit, now this is the mRNA strand, right? Each group of three letters, as we've talked before, is called a codon, mRNA. That piece of mRNA needs to leave the nucleus. It leaves throughout a pore in the nuclear membrane, and it floats around in the cytoplasm until it's bound to a ribosome. The ribosome will bind to it. It makes that sound. All right, it clamps onto a piece of mRNA, and then we'll read one codon at a time, a piece of mRNA, and it matches up the codons with what are called anticodons found on tRNA molecules. So tRNA molecules bring amino acids, and they also have the anticodon, right? And if those match up, they'll drop off that amino acid. Right, here's tRNA. This is called translation. tRNA bringing amino acids to the ribosome to match up with the codons of the mRNA molecule. Right, tRNA is also made out of it's a nucleic acid, right? And tRNA. And at one end is the anticodon. The other end is an amino acid, right? So these guys float around and they match up their anticodon with the codon at the ribosome, and that's how they know which amino acid to add to the chain. Right? So you make a protein by just adding amino acids together, and then because amino acids have a different our sizes and shapes and might have different charges, that causes the protein chain to bend and fold and make that shape that's so important to proteins. Hey, there are 20 amino acids. You will not have to memorize all 20 amino acids. but you need to know that there are 20 of them, and it's the 20 amino acids put together in different orders that make all the different proteins in our body. You will have to be able to read this chart. Okay, this is a chart that has the RNA, right, codon, and its corresponding amino acid, right? And so the way you read this chart is, so what's the first letter in the codon? Okay, it's C. What's the second letter in the codon? Okay, it's C. What's the third letter in the codon? Okay, it's C. C, that codes for proline, which is an amino acid, right? So we've talked a little bit about this. Here, let's try some. Good. It's not that hard, right? You just match up every 3 codons is equal to an amino acid, and that's how you make your proteins, right? You've got, right, 3 codons make up the amino acid. That's how that works. Transcription and translation, it's kind of like replication, except for you make mRNA instead of another strand of dRNA. So you're only copying half of the DNA molecule. You're just copying a section of it instead of the whole thing. And it involves ribosomes in the cytoplasm with tRNA molecules finding amino acids and matching up with what's called an anticodon to the codons on the mRNA molecule. And of course, we've studied how to read an mRNA molecule, right? Every 3 letters is a codon, and you keep adding amino acids until you get told to stop. And then you stop and you have a protein. Voila. All right, great.